I'm going to introduce Dr. Winslow, and he's going to come up here. He received his Bachelor's of Science from Ohio University and both his Master's and PhD from Bowling Green State University. Since 2004, he's been a fixture at the Ohio State's Stone Laboratory, first as an instructor and research supervisor, but now as the director of both the lab and the Ohio Sea Grant College program. Prior to joining Ohio State and Ohio Sea Grant, he was an instructor at Bowling Green and an assistant professor at Kutztown University of Pennsylvania. Would you please give a warm welcome to Chris?
Thanks for that introduction. I always hate when you guys clap before I talk, because then the bar is set too darn high, and I'm gonna miss it. I'm gonna sit. I'll do a little bit of walking, but the shark attack has taken me off my legs. That's what I keep telling people, not the ice in my driveway. So let's get some logos out of the way on the screen. And so what you're seeing, what I'll draw your attention to is this dark blue, light blue logo, and I'm actually gonna walk because the laser pointer is a little hard in these scenarios. But this logo right here is because we get federal funding to do the work I'm gonna talk about right now. So we get money from what's called the National Oceanic and Atmospheric Administration, because we are a Sea Grant program. So that's what this Sea Grant Ohio logo is here. My mission from that federal funding is to find out what the issues are in Lake Erie, fund research with those dollars to address those issues, and then because I come from this academic PhD world, I've quickly learned that we scientists are horrible at telling you what we do. So what a Sea Grant program is supposed to do is when I conduct the research or my colleagues conduct the research, I need to work hard to get it into your hands. Because the research is just a brick of knowledge that goes into some obscure science journal if we don't connect that information to you. So that's what this logo is, my NOAA funding and the fact that I'm a Sea Grant program. We're not the only one. Any state that bumps into the Atlantic, the Pacific, the Gulf, or one of the Great Lakes has a Sea Grant program. There's 34 of them. Okay? But what we deal with in Lake Erie is very different than what Georgia and Alabama and California are dealing with. The other logos you'll see up here are Ohio State. So I'm at Ohio State University because they own this island that I get to spend part of my year on. So it's an island in the western basin of Lake Erie. And I wanted to make sure you knew that not only am I with the university, but I'm specifically within the College of Food, Ag, and Environmental Sciences, where OSU Extension resides. Because OSU Extension is a great example of that idea of connecting research to audiences. And so we have an extension educator in the room, and that's fantastic to see. So here's the history of blooms. So these are basically from 2002. If there's ever a number up here, I'll let you know what it is if you can't see it. So from 2002 all the way to 2017, warm colors mean intense bloom, cool colors mean light bloom, and black means no detectable bloom. I use this to show you that these blooms vary from year to year, but they have clearly been around since the late 90s, early 2000s. Okay? What I will show you too is 2011, second worst bloom on record. See where it's located, all the way out east towards Pennsylvania and New York. 2015, worst bloom on record. Look at that coverage during that year. But I also bring this up because the number that keeps floating around is that we need a 40% reduction in phosphorus. If you're going to reduce something, you got to reduce it by what? Right? So relative to what? And so what I wanted to show you is this is 2008. When you hear about a 40% reduction in phosphorus, it's relative to the amount of phosphorus that came in 2008. Won't go into tremendous detail with this, but basically we picked 2008 because it was a fairly wet year. It was a heavy water year. And so the idea is if you're going to pick a threshold to hit, you want to have it on a wet year so that in a dry year you more than exceed that reduction that you're looking for. So that's just to kind of set the stage for us. Next I want to talk to you about this. Okay, state of Ohio, the polygons you see within that state are the 88 counties that make up Ohio. I'm going to talk to you real quick about the economic impact of tourism in these 8 counties. So that red line highlights the 8 of 88 counties that touch Lake Erie. The numbers, again, if you can't see them, I'll read them off to you. Tourism sales bring in about $15.1 billion in revenue. To put that number in perspective, the entire state's tourism revenue is about $40 billion. So it's telling you that about 30% of all the tourism dollars that come into the state of Ohio are coming from only 8 of 88 counties. It highlights the fact that Lake Erie is one of the jewels of the state. You'll also see the wages that are earned. So people that work in the tourism sector are bringing in about $4 billion. Taxes generated by tourism, local, state, and federal, are bringing in about $1.9 billion. And jobs About 128,000 people are employed in tourism in those 8 counties. To put that number into perspective, that's about 1 in every 12 people in those counties has a tourism job. Okay? So I use this slide to illustrate the importance of having a healthy Lake Erie, a bloom-free Lake Erie. But I'd be remiss if I said that's the only reason we care about the lake is because of tourism. So I'm going to put up a little text box here, and I'm going to highlight some other things we need to be thinking about as we talk about HABs and nutrients. Okay, HABs is harmful algal blooms. The text box I'm going to put up here is not exhaustive. Not everything's listed here, but it's just to get our brains kind of thinking about this issue. The first one is the cost of removing toxins. When these blooms show up in Lake Erie or any inland body of water, they have the potential to produce a toxin. That toxin has liver impacts, can have dermatological skin impacts, and so to get that toxin out of the water is expensive. For example, Toledo, when the blooms are on the lake, they're spending approximately $10,000 extra per day to remove that toxin from the drinking water. So to remove these blooms, we save that investment in water treatment. The next one is the cost of communities with drinking water advisories. We know that in 2014, we had what people refer to as the Toledo water crisis, and we had to basically avoid the water for 72 hours. I've seen multiple economic studies sliced in different ways, and the numbers are coming back somewhere between $2 million, $10 million of economic impact from that shutdown. So removing the blooms and their associated toxicity saves those local economies. Charter captains and marinas. I get to work with the charter captain industry on a regular basis, and basically they are seeing clients that regularly come up to the lake to fish, not renew trips and not come back up again. Okay? So that industry of fishermen and the charter captains are losing some revenue. Same thing with marinas. We work closely with all the marinas that dot the Lake Erie shoreline, and they are showing an increased number of slips that don't have boats in them because people just aren't putting their boats in the water because they don't want to be recreating on that green lake. As far as the fishery, in Lake Erie, I've seen numbers around $1.5 billion revenue brought in by the fishing industry. We are now starting to see that the vision of fish in these blooms is impaired. Their ability to see and detect predators and prey is being impacted. We're also seeing evidence that ties to what we call a dead zone. It's a creepy word. I didn't invent it, but it's out there. Dead zone refers to parts of the lake that don't have oxygen at the bottom. If you don't have oxygen at the bottom, those fish can't live there. This happens because these blooms, these huge growths of algae, when they eventually die and sink to the bottom, bacteria start to decompose them. And as they decompose that bacteria, they suck the water out of the lake. Oxygen. Oh, sorry. Thank you. Good. Somebody's here to help me through this. I didn't have my quota of coffee today. You'd hate to suck the water out of the water. Then we have a big issue. Jeez. Started off on the wrong foot. Same thing with Cuyahoga. I was joking about that. When water catches on fire, that's a bad sign too, right? So let's avoid that. They didn't. Good news, this is the 50th anniversary, I don't know if it's one you want to celebrate, of the burning of the Cuyahoga River. But if you're in Cleveland this summer, there's a lot of celebrations to talk about the great successes since that kind of blemish on our record. Last bullet here. I will tell you, this is the slide that I present everywhere I go. Whether I'm sitting with a bunch of producers or environmental NGOs or with tourism people, that last bullet is always there. Because as a scientist, all I do is collect the data and communicate that data to you. And so what I need to show you is that when I present on this topic, I always make sure that I talk about that last bullet in what I call a win-win. One win is that we need to clean up the health of the lake, right? We need to get rid of those algal blooms and their associated toxins. But the other win has to be that we do this without impacting agricultural productivity in the state. It's critical. Because I'm showing you tourism numbers here, but if you put the ag numbers up here for wages and salaries and employment, it's going to blow these tourism numbers out of the park. Okay? And so what we need is a win-win situation where we adjust the lake condition, but not at the expense of revenue and jobs related to ag. Okay? And I have to get that out in front of you right now because some of the slides I'm going to show you coming up is that the vast majority of the nutrients, specifically phosphorus, driving these blooms is coming from runoff from agricultural practices. As a scientist, that's not me saying, come on, stop it, you guys. What that's saying is, that's the source. So now we need to collectively work together to figure out how to reduce that source. To identify that this activity is the largest contributor is not to say it in a punitive or accusatory fashion. It's just to recognize those are the numbers and let's get after them. Why Lake Erie? Why does the western Lake Erie basin seem like this canary in the coal mine? So I'll show you this graph. This is the 5 Great Lakes in depth profile. We won't argue today whether Lake Michigan and Lake Huron are 1 or 2 lakes. That is a debate in some circles, but let's call it 5 Great Lakes. What jumps out at you from Superior, Huron, Michigan, and Ontario and Lake Erie? What jumps out at you here? Depth. Lake Erie's tiny relative to the other 4 Great Lakes, right? So the problem with this is that anything that runs off the landscape into the lake doesn't have the ability to be diluted. That was our environmental movement in the late 60s, early 70s. The solution to pollution is dilution. We don't have that luxury, right? And so what we need to know is that any nutrients inputs that go into Lake Erie, they have the potential to be exacerbated. But rather than just show you a picture that shows that Erie's the southernmost, the shallowest, I can show you this. I'll walk you through it. I apologize. I'm a scientist, so I always have to have graphs, but let me walk you through it. Vertical height is percent land use. Each bar represents a different Great Lake. I will put a box around Lake Erie so you know where we're drawing our attention. The colors within that bar correspond to what the land is being used for. The light blue at the bottom is urban. We have the most people in our watershed. Close second is Michigan because of what suburban area? Actually, Chicago, right? Chicago and its suburbs. So we have all these people. I can pretty much guarantee that all of us probably went and flushed a toilet today or did some kind of activity in our household that contributes nutrients to a wastewater treatment plant and then the resulting discharge into receiving water bodies. So when we talk about nutrients in this harmful algal bloom, we can't leave people out of that equation, our urban and suburban centers. The next one is ag. Minus Ontario, which is a close second, we are first in the amount of acres in the watershed that are in ag production. We have manure application and we have commercial fertilizer application. It's what we have to do to produce the crops that we do. But it means that we have a large component of that watershed that has the potential to contribute nutrients to the system. The gray bar is grasslands. It's pretty negligible, so I don't ever talk about it. The yellow is forest. We have the least amount of forest. I bring this up because this is kind of thought of as the pristine condition, a land use that doesn't contribute a large amount of nutrients. The last one is wetlands. You can say that we're the least. It's the skinniest bar at the top. But I will tell you, I don't ever put the word least up here. I put the number 10%. This reminds me to tell you that we only have about 10% of historic wetlands remaining. The rest of those, 90%, have been filled in, drained for agriculture, or converted to urban and suburban centers. Okay? I am not standing up here telling you that we got to go back and convert it all to wetlands again. It ain't going to happen. Right? We can't take the use we're using for now and convert it all back to wetlands. We can maybe identify some pockets or places where a wetland might do a good job in removing nutrients. But we do have only 10% of historic wetlands remaining. And think about it. Toledo, if you read any historical documents about it, it was referred to as what? Toledo, what? Great Black Swamp. Most people say Black Swamp, but everything you see is going to say Great Black Swamp. Okay? So just to get away from figures and text, let's show you some pictures. This is a Canada goose up by our island, 2011, second worst bloom on record. Canada goose. They hate to be called Canadian. Don't do it to them. Canada goose. But leaving a track in this, what looks like pea soup or spilled paint. This is a colleague of mine working for the USGS. Okay? The wake behind that boat is a thick, viscous bloom of algae. Okay? During August and September, late July, August, September, this is something that you can see on the lake. All right? This image, there's the full Lake Erie. Here is Lake St. Clair. This is going to be your Detroit. Here's Toledo, Cleveland in its suburban area. Look at that bloom in the Western Basin. Again, 2013, this is the third largest bloom on record. In this scenario, if you went to Maumee Bay State Park and tried to look at the Canadian shoreline, you would not be able to see it. The amount of water between you and Canada is so vast, you can't see the other side. If you know that half the water between you and what you can't see is a bloom, that is a large bloom. I'm leading you with the title on this slide. Is this just a Western Basin problem? Fortunately, no. In this scenario, 2011's second worst bloom on record, it's pretty much out of the Western Basin. It is now in what's called the Central Basin, and it's out east of Cleveland. What you also notice from this picture, where else is this bloom? Canada, right? So I can tell you there are investments and research and efforts going in the Canadian production lands to also address some of these issues. I'm leading you again. Is this just a Lake Erie problem? And clearly that isn't the answer. If you go to your search engine on your internet and say harmful algal bloom in Ohio, these images will pop up. Okay? So we've got Grand Lake St. Mary's. Never good when the Shamrock Shake from McDonald's rolls up on your beach. That's a sign that things aren't good right now. Right? Ohio River picture tells me to remind you that in 2015, when the largest bloom was on Lake Erie, the entire stretch of the Ohio River from basically Pittsburgh all the way to Cincinnati was one contiguous bloom. Okay? So I want to transition now and talk to you about the research that's ongoing right now. And this is part of the fun part of my job is we don't just do the research, but I get to start talking about what we're doing in this space. So after the Toledo water crisis in 2015, our state's Ohio Department of Higher Education put in play $2 million a year, starting in 2015, and we have the last slug of money in our pockets right now, to fund research to help with this issue. My mission, so I'm co-managing these grant dollars from the Ohio Department of Higher Education, is to approach our state agencies, Ag, Health, DNR, and EPA, and say, for you to do your job as an agency, what do you need to know about HABs and toxicity? And that's what we told the academic researchers, you need to figure out ways to answer these questions that are coming from these agencies. There's about $3 million worth of projects already done, $3 million in play right now, so I'm not going to bore you to death and talk about the 50, 60 projects that are going on or are finished. But what I will do for you is talk about the focus areas or the direction that those classes of projects fell into. So the first one is produce safe drinking water. If these blooms are producing toxins, we can't have another Toledo. We have to know that our water treatment facilities have the tools and technology to remove that toxin. So this is where a lot of research went into. Some cool things I can tell you in here without getting into the weeds. Things like, you know that carbon absorbs basically everything. It's in our water cartridge filters in our fridge. Okay? So you would think, let's just throw carbon or charcoal into our water treatment facilities and it'll get rid of these toxins. Well, we didn't know how much you add relative to the concentration of toxins. We didn't know, do you want it to be granular or powder, so it gives more surface area to absorb those toxins. So a lot of research just had to go into figuring out how to treat and remove those toxins. We now have biofilters that have micro nanotubules that are basically screens that allow the water to go through but are small enough pores to hold the toxin back. They're studying using UV radiation and ozone. They're bubbling ozone into our water treatment facilities to remove these toxins. None of those things were refined or being used until this research effort. The next one is human health risks, right? We need to know if we are coming in contact with this, what is it going to do? And is it one large dose that I get exposed to that makes me ill, or is it small concentrations every day if I'm a charter captain that spends my livelihood on the water every day? And so a lot of this human health risk stuff was going on. To give you an example of this, if you fell ill and you were swimming in a lake that was green and you went to the doctors and said, hey, I'm not feeling well, historically they would not be able to diagnose whether that was some ailment or the toxicity. Because when that toxin enters your body converts it to another chemical format. So the doctors wouldn't even know what to look for. Now we have the ability that they can take urine samples and blood samples and know whether it was in your system or not. We have a project going on right now to see how much exposure are people getting if they go to the beach and the waves crash with toxicity and they're breathing it in through their nose. Okay? The next one is how blooms behave. And this isn't like temperament of my children at home. This is where are they in the water? Are they at the surface, which is where they like to be? Or are they mixed down to the bottom of the lake where the water intakes are taking water in? Right? We now know that for a single cyanobacteria, that's what these blooms are. People call them algae blooms, but it's actually bacterial colonies. For a single bacteria to produce that toxin, it needs to have 10 genes. Just like our eye color and our hair color is dictated by genes, if a single bacteria does not have all 10 of those genes, it can't produce the toxin. Chris, why do we care about that? Well, because now we can go out and sample that bloom and look at the genetics and say only 10% of the critters in that bloom are able to produce the toxin, so likely that bloom won't be that toxic. Versus going out and taking a water sample and saying, oh my gosh, 99% of the bacteria in that thing can produce the toxin, well then we know we have a potential highly toxic producing bloom. Now before I show you the last category, you might ask me is, why these three things? Right? Why don't we just stop the blooms from happening? Well, we approach this problem kind of as a triage, right? We know that we need to clean the water today. We need to know what are the impacts today. And we need to know when is it going to produce toxins or not produce toxins today. Those are somewhat easier questions to answer than the larger one that I'm going to put up here, which is addressing nutrient runoff. Okay? This is going to be the heavier lift. This is something that we can't find an answer and implement today. Well, we can implement it today, but it's going to take a while to run its course. If the general public, and I try and get out to as many talks as I can, doesn't recognize that The situation we're in right now can't go away overnight because we have a heavy lift out there to reduce the nutrient inputs that are going into the system. Okay? So now what we're looking at is nutrient runoff into aquatic ecosystems. As I said, 3 million completed, 3 million ongoing, and we have some more to come. I stand up here and I get to give this presentation a lot, but I can't make you think that this is all me. I send a lot of emails during the course of the day. That's kind of my job. This is kind of the brains behind this scenario. Every university on the bottom has got some sort of funding to help do this work. On the top right reminds me to tell you again, we don't fund a project unless EPA, DNR, Health, or Ag says it's important to the management of that system. This isn't just a bunch of kooky scientists sitting in a lab saying, you know, that'd be fun to run that experiment. This is driven by agency priorities. The next thing is we have the NGOs at the table. I'm glad Jordan's in the audience. Farm Bureau is always at the table for these talks because we need to know that the academics understand the reality on the landscape with the farmer. Okay? And then other things. We have federal funding. Again, federal funding from the Sea Grant, USGS, USDA, NRCS. These people all have to be at the table. Because what we've learned, those two spin because I'm up here for Ohio State, but in this grant collaborative, I'm co-doing it with the University of Toledo. I've got to give the University of Toledo a lot of props for all the work they're doing. But what I thought was going to pop up is this. As we address this problem, it has to be truly collaborative. We need to be working with the farmers, the academics, the agencies, and stakeholders, meaning the charter captains and the tourism business. We can't be trying to solve these problems in a vacuum by ourselves. So let's start getting into the nutrient sources today. So where are these nutrients coming from? So for us, the Maumee and the Sandusky River, which both dump into the Western Basin, are the largest phosphorus loaders. 87 to 93% of the phosphorus is coming from non-point within these systems. Non-point. What that means is that it's not coming out of a pipe. Point source means the phosphorus is coming out of a pipe. You can point to it. It has an address. This is telling you that most of the phosphorus in these two rivers isn't coming out of a pipe, it's coming off the landscape. Okay? Within these same two rivers or watersheds, ag is dominant. Greater than 70% of the land in these two watersheds is ag. Okay? I will put my caveat out here, fancy biology phrase, correlation is not causation. What I mean by that is ice cream doesn't cause shark attacks. We eat ice cream in the summer, and that's when most shark attacks happen. Just because they're aligned doesn't mean one caused the other. Correlation is not causation. So what I'm telling you is here, just because non-point is high in these two regions and ag is the biggest non-point contributor, we're not saying that this is 100% tied. But logic kind of dictates that it is. We're saying that even if you get the same amount of phosphorus runoff from my lawn in my suburban neighborhood, just because the vast majority of the landscape that is ag is going to be a larger contributor. Moving on, we now know that EPA is working on this. EPA has been mandated to do what we call a nutrient mass balance. So they go out and they have data on every point source. Every pipe emptying into the water, they have measured that phosphorus and know how much is being contributed there. So that means by the math, the rest is that remaining non-point. But what we're trying to do in every one of our tributaries now is go and say, this tributary is contributing this amount of phosphorus from non-point versus this tributary is contributing another amount of phosphorus so that we can kind of target where we might need to be going. This reminds me to tell you, we can't walk out of here just blaming phosphorus. That's what we hear, 40% reduction in phosphorus relative to 2008. What this reminds me to tell you is that 70 to 90% of the loading going from the land into the water is coming during heavy rain events. Okay? 20% of the highest flows contribute 70 to 90% of that phosphorus. This equates to roughly 10 storms a year. Okay? Sad news if you weren't already ready. We know the time period of phosphorus inputs that drives the summer blooms. The window is from 1 March to the end of July. We're in that window. So any heavy rain event that happens from now until the end of July, that's the phosphorus that's leaving our landscape and driving these summer blooms that happen in late July, August, and September. Good. Nutrient sources today. So when this problem first happened, everybody was like, okay, where's this coming from? Let's drill down and figure it out. So we have spent a lot of time gathering data on sources of nutrients. WWTPs, that's wastewater treatment plants. EPA monitors every pipe that comes out of every treatment plant, and they know that phosphorus contribution. From the 70s to now, we've seen a 75% reduction in that contribution. And this happened because of the Clean Water Act, right? Clean Water Act, we had a dead lake, we had these dead zones that were going crazy, algal blooms all over the place. And what happened is with most of that phosphorus is coming from wastewater treatment plants. So the Clean Water Act and the federal EPA basically dumped in billions of dollars to rebuild or upgrade all of our wastewater treatment plants so that they could remove that phosphorus. In addition, does anybody remember what other ban came in place this time? Late 60s, early 70s? Phosphorus in our detergents. So we pulled phosphorus out of our detergents because the wastewater treatment plants were contributing too much, so we needed some upgrades there, but we needed to start pulling the phosphorus out of our detergents. The lake recovered into the late 80s and early 90s. Okay? So if you add up all of these wastewater treatment plants, they only contribute about 9% of the phosphorus to the system. Now, even though that number is low, I'm here to remind you, and I tell this to every audience I'm with, if we need a 40% reduction, well, then that 9 better become a 5%. If we're going to ask ag to cut from wherever their contribution is to where they need to be by 40%, then we need to do it in this sector too. The next one is CSOs. Who knows what a CSO is? Combined sewer overflow. So some of our older cities, all the water that comes out of your house joins up with all the water coming off streets and parking lots and goes to the wastewater treatment plant. Great on a normal day because they can treat that water. But if you have a storm event in concert with that, now you have this extra water coming into these wastewater treatment plants and they can't treat that volume of water. So a CSO basically is a raw discharge of untreated sewage. Okay? We know where these are. And actually by 2020, 40 of the 62 communities will have taken those CSOs offline or found ways to hold that water back so it can be treated. But even if you add all of these up, and this was in 2013, the third worst bloom on record, so a very wet year, all of those CSOs combined only contributed 1% of the phosphorus. Now I'll pause here. That's not me saying don't fix the CSOs, right? Because it's those CSOs that close our beaches and put viruses into the system. So for other health reasons, we don't want raw sewage going into our systems. But we can't blame CSOs on the bloom problem because it's only 1% of the phosphorus. The next one, we know septic systems are contributing. It depends on where you are in the state. Some are more contributors than others, but as a whole, across the state, we're hearing somewhere between 25 and 30% of septics are not working. But even if you attribute to all those septic fields and add them all up, it's still only about 4% of the phosphorus. Again, I'm not saying that means we leave septic alone. I'm just saying the amount of money and the investment and the time that we put into that, we've got to think about the bang for the buck. Scott's Miracle-Gro, since 2013, they've pulled phosphorus out of all of their lawn maintenance fertilizers. Scott's did an exhaustive study showing that the phosphorus, background phosphorus in our lawns, in our suburban and urban areas, is enough to grow a grass. If you're going to put new seed down, there is a starter fertilizer that has phosphorus, but once you have established roots, it will grow without phosphorus. Okay? Thankfully, Scott's was about 95% of the market in this area, so everybody fell in line. So if you go into Lowe's, Menards, Home Depot, Ace, and grab a random bag of maintenance fertilizer off the shelf, there will be zero phosphorus. Okay? And last but not least, internal loading. People thought early on that maybe this is phosphorus that we've been putting in the lake for years and years and years and years, and every time you have a storm, it gets mixed up and put back into the water column. That's internal loading. So in 2013, again, a bad bloom year, a wet, stormy year, we had teams of scientists that went out through different experiments and tried to measure that phosphorus coming from the bottom back to the top again, and only 3 to 7% of the total phosphorus in a given year is coming from that source. So if you add all of these up, it's about 21-ish%, somewhere in that range. The rest is coming back to ag production. Now, when I say that, again, that is not me angry or pointing fingers or suggesting regulations or punitive damage. It's just the reality. And so now what we need to do, from my point, as a research academic community, is give producers the tools to start addressing that nutrient runoff or input. Understanding ag loss. So in the 70s to 90s, we were applying 10 to 40 pounds P2O5 over crop removal rates. We know this, and the extension folks again in the we know that we were saying you could bank phosphorus. If you had a good year, put it out there, it'll wait for you in those lean years. We now know that we were over applying for removal rates, and it resulted in an accumulation. Okay? So what I want to show you though is since the mid-90s, so this is over application, 10 to 40 pounds over, since the mid-90s, we are now 2 different studies I'll show you. One came out of Mullins, showing on average about 5 pounds below crop removal rates. And you can see this in fertilizer sales. We're seeing these numbers come down. Another study, this was done by USDA, so the NRCS, they actually looked at a different set of data and analyzed it slightly different. They're saying on average, that's the key, 5.5 pounds above. So these are off. One is saying below, one is saying above. But what's more important about the NRCS data is that they showed, on average, it's a little bit above, but they're also showing that 58% of the fields they sampled are putting it below crop removal rates. So if on average we're 5.5 above, but more than half, 52% of the fields are putting below, that means there's some fields out there that are putting on a lot. And that's what the data bears out, because the same study says 42% of the fields are accounting for 78% of the phosphorus loss and 80% of the sediment loss. This reminds me to tell you, a field is not a field is not a field, right? There are going to be fields within our watershed that are going to be contributing more than others, okay? And so these blanket statements about ag needs to do this, producers need to do this, there isn't a silver bullet out there that everybody can implement and the problem goes away. We have to think about, I hate using this word because it sounds malicious, but we need to think about targeting to those 42% of the acres. Not in a punitive way again, but just finding where they are, and let's put our resources where we're going to get the best bang for that buck. I'm going to pause here with the title before putting anything else up here, because I'm trying to learn a lot about producers in the ag world. So this is my opportunity to tell you about the crazy, kooky science world that I live in. We are directionally correct. What this means that if any of my colleagues, if you bump into a scientist and they say they proved X, you have my permission to grab their ear and yank on it really hard. There is no proof in science. We have a question, we collect data, and we make conclusions about that. I learned this when I was in 7th grade. You can't prove that all crows are black, because when you wake up one morning and there's a white crow on that fence post, you're in trouble, right? These are educated guesses. But I put this title up here for a very specific reason. We are directionally correct. We have addressed this with many research projects, different methodologies, different approaches, and it's all pointing, the way I'm going to populate this slide, is to the same things that we need to be doing across the landscape. What scares me about this, and this is why I say directionally correct, because I don't want to stop, and I'm going to say this sentence twice. We cannot stop progress for perfect. If there's no proof in science, you're never going to get a proof from science. That doesn't mean you just sit back and say, the scientists can't tell me this is absolutely going to work, so I'm not going to do it. We don't have the luxury of waiting to stop progress for perfect. So everything I'm going to put you up on the slide, we have data, lots of data in some instances, to back up that this is a good bang for our buck. And I'm going to lay them out for you. First one is the 4R nutrient certification. For us, it was Senate Bill 150. Here they are, right rate, right place, right time, right source. A lot of data that backs these up. Okay, so for the right fertilizer source, are you going to use manure or commercial? Right time, not ahead of rain, not on frozen ground. As far as the amount, we got a soil test. And you're going to have a great talk by Aaron here in a little bit talking about soil testing. And then this right place, injecting, subsurface placement. Actually, I'll leave it there, subsurface placement. This is great. I don't have my wallet on me right now, but I have my little yellow laminated card. I don't farm on greater than 50 acres, but I'm not going to come and talk to you if I'm not going through the same training that we're asking the agricultural community to do. Okay? Avoiding frozen, so this is now in Senate Bill 1. Can't apply in frozen ground. Makes sense. Ground's frozen. Put the fertilizer on there. When it thaws in the spring, what happens? Running off. Right? But I am trying to educate my academic partners, and anytime I talk to a non-producer population, to say, this makes sense scientifically, don't put it on frozen ground because when it thaws it runs off, but what has that done to the time that you can be on your field? Went from here to here. So when we talk about these solutions, we have to talk about how they fit in the behavior of the community that we're asking to implement these things. Same thing with the next one. Senate Bill 1 is also no rain forecast or saturated soils. The rain makes sense, right? If you're laying it out there and it rains, it's going to run off. A lot of farmers focus on that, but I think we need to be focusing more attention on the second one, which is saturated soils. And this is where you get into that plot. If you say don't apply it when the rain is coming and that's your steadfast rule, what if you haven't seen rain for a month? You might be able to hold that rain that comes 20 minutes after you put your fertilizer on it because the water is going to stay on your field. So with things like this in place, what you've done is winter took your field time from here to here. Now you've got rain from here to here. Now you got saturated soils from here to here. So as we do this stuff, which is again backed up by great science, we need to think about who we're asking to undertake these activities. The next one is eliminate broadcast application, and as I say, subsurface placement. I said incorporate earlier and it kind of slipped out. Incorporate to me triggers tillage. We don't want to go back. No till is good for us, right? Building up organic matter, Okay, so no-till. So what we need to do is, if we're not tilling, what we're doing is broadcast applying. Well, that fertilizer is just sitting on the top, ready to be run off. So we have to find a way to subsurface place, and so we're advocating for things like banding fertilizers and injecting. Again, scientifically makes sense. That costs money. Right? We got toolbars associated with this. How are you going to get that into the hands of the farmers that need to use it? Additionally, I imagine you can get fertilizer on your field pretty darn fast if you're just broadcasting. As soon as you put a toolbar down, you are slowing down on that field. So winter, rain, saturated, toolbar, those farm active days are getting tinier and tinier and tinier. Next one, soil testing. We've got to do it. It's the right rate. Okay? A lot of people early on were saying, well, we can't, I don't want to steal any of Aaron's thunder, but expensive to soil test. Right? What we're seeing, and actually I'm working with Farm Bureau now, Jordan, to talk about this, is if you soil test, there are benefits that come with that. Okay? If you soil test, in many instances, you're probably buying less fertilizer than you did before you soil tested, because you found out some parts of your field already have enough. The others is that we're seeing folks that are identifying places that they were applying a fertilizer, but they should have actually been adding more, and so their yield is going up. So what we're seeing is that between the decreased fertilizer bill and the increased yield, you're offsetting the price oftentimes of the soil testing. Last one is drain water management. We cannot forget, we keep saying phosphorus, phosphorus, phosphorus. We got to control the water. Okay, 2011, second worst bloom on record. You guys remember 2012? What did it look like? It was a drought, right? There was no bloom in 2012 because there was no mechanism to take the fertilizer from the field into the water. 2015, worst bloom on record. 2016, you remember it? Drought. No bloom on the lake, right? Now, those are blooms go away just because we got lucky with the weather. But we are in a place right now, and I'm preaching to the choir here, where we're seeing more frequent and more severe storms. So we can't count on not having a bloom just because it didn't rain that year. Good. What other levers can we turn? Because as I told you, I give this talk all over the place. So if it's not an ag community, they need to know what they can do. So the first one is lawn care recommendations. If you got an old bag of fertilizer sitting, let's get rid of it. Don't put phosphorus on your lawn. And I've told this to my father. If he doesn't have the right hue of green next to his neighbor's lawn, he's ticked off. Phosphorus isn't getting you there, Dad. Okay, so don't worry about applying phosphorus. Property runoff. This comes back to that CSO and needing to control water management. So if you can put a rain barrel out there, or if you've got a steep lawn, let's terrace that lawn. Or porous surfaces. Again, I'm a graduate of Bowling Green State University. If you drive by their football stadium, that parking lot is no longer there. It is a grass field. Why would you pave a big parking lot like that when you've only got people parking on it for 8 football weekends a year? So it's now a porous surface. Okay? Plus, I always joke about this, like we had a gravel driveway when I was growing up. What chore are you going to give your 10-year-old kid besides picking the gravel from the lawn and putting it back in the driveway after you snowblowed the driveway, right? We've got to build character in our 10-year-olds. So let's get back to our porous gravel driveways. Sewage treatment plants in 2 aspects. The one is tertiary treatment. So after it leaves the wastewater treatment plant, it's still got a little bit of phosphorus. Let's start running through constructed wetlands that remove that extra phosphorus. So we can get from 9% of the total phosphorus to a 5% of the total phosphorus. Things like expedite, get rid of those CSOs. Can't have the combined sewer overflows. Granted, it's only 1% of the phosphorus, but it's contributing. And it needs to be on our radar. And the last one is reduce volume, and I always joke about this with my father too, because he's just a crazy man. But we have low-flow toilet and low-flow shower head technology. And I told my father this. I said, no phosphorus under your lawn, Dad, anymore, and convert your toilet to a low-flush or low-flow toilet. And of course, he's going to come back to me and say, I'm not spending $160 on a toilet that ain't broke, right? So I said, put a brick in the tank in the back of the toilet. Because when you put that brick in there, you're displacing the water, so every flush is less water. So then he puts bricks in the toilet, and Mom gets frustrated because she's got bricks in her toilet, so she goes buys marbles from Michael's and puts marbles in the back like anybody's looking in our toilet. But that's the family that I kind of come from in these scenarios. Septic tanks, we got to monitor. Okay, and there is movement in here. We are now seeing low interest or no interest loans to help put these in place. Okay, I've been hearing that some of those dollar amounts aren't enough to do this septic tank upgrades, but we need to more closer monitor that because that's about 4% of the phosphorus contribution. So for me, what are our immediate needs? We're not done in the water treatment space, so we need to continue to arm those treatment facilities with the tools and technologies they need. Second thing is we need to figure out the health risks. We have a decent view into that, but I'm sure there's things that we need to keep analyzing. The last one is we got to get to that 40% reduction. And if there's one thing you walk away from this talk with, I want to tell you about these 3 buckets. This is me telling you, how do we get from where we are to a 40% reduction for our stewardship? You got to follow the right rate, right time, right source, right place. Okay? Some of those are going to have costs associated with, like the right place, because you got toolbars to do that. So that's tough. But the right rate is a soil test. And Aaron's going to talk to you about it in a little bit. I mean, that is a huge piece of information that was introduced in the beginning. Water management. Okay? And I argue that water management isn't really addressed in the 4 R's a little bit with, the subsurface placement, but we got to think about how we hold water on the landscape a bit more. Now, I know that if you have a wet, low-lying field, the best way to get a yield is to get tile drains and get that water off the field. But at the same time, you got to think about the other ramifications for that. Okay? So water management, 2-stage ditches, blind inlets, bioreactors, things like that are good things to think about for water management. And the last one is this legacy P. There are going to be parts within the watershed. We saw from the NRCS data, 42% of the fields are producing 78% of phosphorus. Even if we all do this, which I would argue is phosphorus use today and water management today, we are going to have places across the landscape that are going to contribute well into the future because the phosphorus levels in those soils are so high. We got to find where these are and help to address that source. Next thing I'm going to put up here is, everybody asked me after this talk is over, is can we do this? And as a scientist, I apologize, I'll say in advance, the answer is yes and no. Is this a quick fix? Yes, in terms of if we go from where we are now to a 40% reduction, bloom goes away immediately. We've seen it. Difference between 2011 and 2012, we didn't have 40%, bloom gone. Difference between 2015 and 2016, 40% reduction, bloom gone. That was because of rain, not because we actually changed kind of the behaviors on the landscape. So I think, yes, if we get to a 40%, the problem goes away overnight. The no is in there because I don't think we can get from where we are to a 40% reduction overnight. That's going to take time. And so know that I'm trying to communicate, and so is Jordan and Aaron every time he talks about his demo farms, is that we're trying to tell people that we have to be in this for the long haul. What we're doing today, you might see some reductions in your field, but there's a lot of stuff to be doing between now and the end. Last thing I want to put up, 2 more slides, a couple bullets on each one of these. Again, I tried to illustrate throughout this talk that we've got to not just take the science and have that drive. We've got to have science and farmer decision-making at the table. Let's talk about this. The first thing is that we know that not all best management practices are equally promising from a behavior standpoint, meaning the willingness of a farmer to do these. So from some survey work, we know that 94% of farmers are likely to soil test. They either are or intend to in the near future. It's great. Fantastic. We are seeing from surveys that 94% of farmers are willing or are already doing changing their timing. Not on frozen ground, not on the rain, not on the saturated soil. Cover crops falls to 74%. Either doing it or intend to do it. Why might that be? Why is it lower than the 94%? Right. To put a cover crop out, there is a cost to that. We could argue that just delaying a little bit here, I know that's easier said than done because sometimes you guys get pinched. I know there's a lot of soybeans that didn't get off the field last year. So timing, there is some pain associated with it. But again, soil test is showing increased yield and decreased fertilizer bill. This one, the percent makes sense because it is a cost. And many of the studies we're seeing, you're not seeing a benefit from these cover crops as far as organic material for 5, 6, 7 years after you've started doing that. Because you need time to build up that organic matter and change the soil quality. Then there are the difficult ones. And these are the ones that require incentives. So we have to offset the short-term costs and risk. This is that toolbar. But if I'm going to invest that big dollar amount, I need help to get there. Right? And so a lot of practices, by just saying banning injecting, you can say it and you can show that the data supports it, but getting a farmer into a place where they can actually afford to make that purchase is not easy. So these are some of those difficult cover crops, drainage, water, control structures, bioreactors, doing stuff with these blind inlets. We need to work on these scenarios, but there's a cost to this and not an immediate benefit to that producer. Last slide. Barriers are also linked to legitimate logistical things. So again, access to the equipment. I've already talked briefly about this, okay? So that subsurface placement of banding or injecting. There's a limited windows. So we know that farmers are, the right time not frozen, not rain, not saturated. Sometimes you get to the point where you're like, I can't wait anymore. And that's a legitimate barrier. The last thing I'll leave you with is what we call self-efficacy barriers, self-efficacy or response efficacy. Fancy words for this. Some farmers are experiencing what we call self-efficacy. Some farmers don't know if they can actually put the BMP on the landscape the right way. Why would I spend money on a cover crop if I don't know I can put it out the right way and kill it the right way? Why would I put in a wetland on my land to hold the water back if I don't know if I'm constructing the wetland right or putting it in the right place? So some of that hesitancy is because there is I don't know if I can do it the way I'm being asked to do it. The last one is the response efficacy, and this falls on my shoulders, is we need to be funding more research that shows this BMP gives you this result. And unfortunately, we're not there. Right? We know that, this cover crop scenario might work here, but if you march 100 miles east of that cover crop scenario may not work because of changes in slope and soil type and rainfall. And so we need to show the producer community that what we're asking them to do has the appropriate response relative to their investment. So I'm going to leave it here. I have a question slide, but we changed the order of the speakers, so I'm actually going to segue into I think, Aaron, I think you're next. And so then when we're all done, I will come back up with Aaron and our other speaker to answer any questions that you might have. So I'll stop there and ask Aaron.
Thanks, Chris. That was really great information. I'm glad you shared it with all of us. I loved it when I heard it the first time. It was as good the second time. You were still limping around. I don't know why you didn't get that fixed yet, but we'll work on that. So Chris talked about the issues, the problems, the things we're seeing in Lake Erie, and now we're going to talk about what you guys can do on your farms to try to fix some of the issues that we might be having. So Aaron Heilers is with us. He's a project manager for the Blanchard River Watershed Demonstration Farms Network. That is a mouthful.
Yeah.
Previously, he was employed with the Algal Soil and Water Conservation District as a nutrient management technician and the Miami Soil and Water Conservation District as a drainage technician. He's a certified conservation planner with a specialty in nutrient management planning. He's also a technical service provider, providing guidance to producers with nutrient management and headquarters evaluation. Aaron and his wife, Sarah, have 3 boys and grain farm in Shelby County. Would you please welcome Aaron Heilers?
Well, thank you. Is this on? You guys hear me? All right, perfect. I feel a little bit like a TED Talk here, so a little different than what I'm used to. I appreciate the opportunity to be here. I've got a limited amount of time, so I've got a lot of information that I won't be able to share with you tonight, but I want to plant the seed and offer opportunities for you to come see what we're doing on the farms in person or other places that I talk. But I want to hit some of the high points, and I'm going to piggyback off a lot of what Chris said and show a little bit more in detail a couple of items related specifically to agriculture. So how many of you have heard of the demonstration farms before tonight? All right, we're getting there. It's getting better. So just real briefly, the demonstration farms is a collaboration between Ohio Farm Bureau and the USDA Natural Resource Conservation Service. It's a 5-year project, started in September of 2015 and goes until September of 2020 currently. Hopefully it'll extend beyond that and expand the network out to incorporate other farms, but that's where we sit today. So we have 3 demonstration farms currently that are in the Blanchard River watershed, and I'll show you where that's at if you're not entirely familiar with it and the boundaries of that watershed. But our overall goal is to demonstrate to 3 audiences. We demonstrate to farmers, to the non-farm public, and to policymakers what traditional and innovative conservation technologies are out there, and then we're looking at the economic and environmental benefits of those practices. And I was sitting back there thinking as Chris was talking about what my job is, and it really is to lift up all the work that's being done across the state. I'm not a researcher. I'm not out there doing research like Extension is or what Chris is funding with their programs and other things across the state. Our main job is to bring these things to people's attention and have that conversation with these 3 audiences. Farming, I'll be frank, farming audiences are the toughest to talk to about these things. You get the non-farm public out on the farm, you get policymakers out on the farm, you have a really good discussion about the realities of what's going on in agriculture. So we're testing conservation systems at controlling non-point source pollution. And if you think about your own farming operation, you can basically control what leaves your landscape in three categories. You can do things in the field, you can do things at the edge of the field, or you can do things in the stream. And our goal is that any producer from across the state of Ohio can come to our demonstration farms, and hopefully as we expand to other demonstration farms, and pick and choose which practice is right for their farming operation. Chris mentioned it. You can go 100 miles down the road, you can go 5 miles down the road, and have different characteristics of the farm that make these practices maybe not work for your farming operation. But we want to find the right combination of practices in each one of those buckets that a producer can know with scientific data backing them up that they are going to reduce nutrient loss from their fields, and more importantly, that it is an economical and feasible for them to implement that practice. You can come up with the best solutions out there, but if you don't have the time to implement them, you don't have the dollars to implement them, then those practices aren't going to work in the real world. And that's what we're trying to focus on with the demonstration farms. Real quick, so the Blanchard watershed is right here, Hardin County, Hancock County predominantly, and then skirts over into Allen and Putnam County. You can see where our farms are in the Blanchard watershed, so one up north by Findlay and then two by Kenton. Real briefly on the particular farms themselves, Statler Farm is a 7,200 head wean to finish swine operation. So a large livestock feeding facility. They also farm about 1,000 acres of corn, beans, and wheat. The other two farms just north of Kenton, Kurt Farms is about 500 acres of corn and beans, and Kellogg Farms is about 5,000 acres of corn, beans, and a little bit of wheat. As conservationists, we have to be able to reach each one of these segments of farming. I think we have a pretty nice cross-section of agriculture here and representation of Northwest Ohio agriculture. A large livestock facility like the Statlers gives us the opportunity to bring in the non-farm public and talk about why animals are raised in the fashion that they are in today's modern livestock housing. Livestock that has the target on their back from the city of Toledo and their residents with what's going on up there. And so that gives us the ability to bring those folks in and let them see. And 9 times out of 10, by the time they get out of that barn, they have a much better understanding of why animals are raised that way, and they're not so quick to point the finger at manure as being the main source of the problem. The other two farms give us the opportunity to talk about the scale of economics. A 5,000 acre farmer can implement different practices than a 500 acre farmer. I farm 100 acres. I can't afford certain toolbars that we're talking about. I can't spread that cost out over my farm operation like a bigger farm can. So we have to be able to speak to each one of these segments and make conservation work for their farm operation. So you won't be able to see this in the back very well, but just briefly about how each farm is set up. Kellogg Farms have about 300 acres in our program. The things that they're doing on the 300 acres, they're doing on 5,000 acres, but from a contractual standpoint, they have 300 acres. We took those 300 acres and broke them into about 70-acre tracts. And then basically, they've transitioned, are transitioning to a strip-till, no-till farming operation. They were conventional tillage on everything, and so we basically have 4 zones set up where we're measuring their conventional system here compared to this one here has wheat in the rotation, so we've added wheat back in, and then just a corn bean rotation with a cover crop on these zones 1 and zones 4. We're looking out over the next 5 years of this project, looking at the economics of somebody that's transitioning to these types of practices. Does it make economic sense for them to implement strip tillage? Can they do the yields hold up as we transitioned into no-till? How long does that lag time take? Can we shrink it down by adding wheat into the rotation, by adding cover crops into the rotation, and then comparing that back to the conventional tillage system? excuse me, the Statler Farms. They have the edge of field monitoring on one of their, two of their fields. I'll talk about that here in a minute, but since they are the livestock facility, we are looking at manure and using how they utilize manure on those cropping acres. And I'll jump into that a little bit more in detail here in a minute. And then Kurt Farms is located right on US 68. They have the unique opportunity that they had a two-stage ditch installed before we came into an agreement with Chris. Hardened soil and water, and the Nature Conservancy constructed that back in 2014, I believe. So that cuts through the middle of his farm. We also have edge of field set up on his farm, and he's transitioning to no-till as well. And that's what we're testing on that particular site is how much from a conventional system to a no-till system are we losing from the edge of the field. So I mentioned it briefly there, but the backbone of what we're doing and what I highlight everywhere I go is the edge of field monitoring by USDA Ag Research Service. This is managed by Dr. Kevin King. It's a little hard to see. The black dots up here indicate each one of the sampling points that he has across the state, but he has 20 sites, and maybe he's added a few more in the last couple of months, but 20 paired sites. So those pairs are two fields that are side by side or in close proximity to each other, and they're being measured over the course of one cropping rotation. So corn, beans and wheat, maybe it's alfalfa, but they're being measured for that crop rotation. At the end of that cycle, they'll switch one of those fields and implement a different conservation practice, and then measure them again for another cropping rotation. They're measuring both the surface and subsurface drainage from both of those fields, so 4 sampling points at each one of those locations. This is a video, hopefully it'll play here. Here we go, of what the sampling location looks like. So subsurface drainage, that little white pipe there is taking a sample every 15 minutes during a rain event approximately, and about every 6 hours during a non-rain event. Doing that on the surface and then on the subsurface and then on the surface as well. And so this gives us the ability then, as this data starts to come in, and again, 20 sites across the state, we're 2 of those sites. This is how we can tell what conservation practice is making a sizable impact on reducing nutrient loss. That's the overall intent. So if we're going to tell folks to put cover crops out, let's make sure that we know what's actually the result of what's leaving that field. Some of the results may not be what we think, and maybe that's not a practice that we promote in certain situations. So that's the overall concept of the edge of field monitoring program. These are the lists of the treatment practices that they've got in place. Again, in-field, edge of field, in-stream, as I mentioned, heavily focused on the 4 R's. So looking at no-till versus tillage, placement of below ground versus above ground, edge of field, drainage water management structures. We've got the 2-stage ditch over here. So a variety of practices that they are implementing and measuring. I'm going to jump back to the Statler farm here real quick, and this is a unique opportunity for us because it's the only one that has liquid hog manure that's being measured at an edge of field site. You can't read this, but basically what we're measuring here on these 2 fields. So this is one field here, and then this is the pair over here. This is in wheat this year. We're going to come with a top dress here this March, April. We're going to top dress one field with manure. The other side will get commercial fertilizer. After the wheat is harvested, that side that got the top dress of wheat, the top dress of manure, won't get anything over the summer. And then when we plant the corn crop the next year, we're going to do Glenn Arnold's work. Everybody's seen Glenn's work with side dressing manure on standing corn. We're going to do that on this south side of the road here and compare that to a traditional manure application after the wheat comes off, put on a 3-year crop removal rate and measure that then over the next 3 years. And that'll be a real interesting study to see because we know the economics from Glenn's work is penciling out. But what about the water quality side of things? So again, to highlight what Kevin's doing, this is a busy chart, but I'll focus you down here at the bottom of the chart. This is, each one of these bars is the one of those paired locations. And the red line that's dashed across there is what the recommended allowable discharge, I'll say, from your farm field is. That's what the science is leading us to, is if we're below that line, then we should have a healthy lake. So you can see, this is the annual for the last 5 years here. Most of these fields, these 20 locations, are right at that line. Maybe a little bit above, maybe a little bit below. And then we do have some outliers here that are significantly higher. But if you look at that as a whole, I think that's pretty promising. Again, they have a pretty wide cross-section of fields across the edge of field network. And if that many of the fields are that close, kind of to Chris's point, we need to target our efforts on certain fields if we know where they are at. And these other ones are maybe 1 practice, 2 practices away of getting below that threshold. So again, piggybacking off of Chris, what those recommendations are telling us is focusing on the 4 R's, developing a water management plan for your farm operation, slow that water down, stop it in some cases, treat it in some cases, but don't let that water run off the landscape as quick as what we're doing right now. And then the last thing is making sure that our soil is staying in place, reducing soil erosion, because phosphorus is tied to that sediment in some cases. Real quick, if I've got just a few more minutes here, I mentioned soil testing. So one of our fields we soil sampled on the same day. We soil sampled 3 different ways just to give a sense of what those results would come back at. And this highlights the importance to me of soil sampling. So you can see we did grid, we did a standard, and we did a zone soil test. And if you focus here on the map, because this particular farming operation used commercial fertilizer, you can see the difference that came back from those 3 soil samples. 8,500 pound difference just on one field by increasing our level of management and soil sampling data that we're pulling. So to Chris's point again, you don't know, if you don't know what's in your soil, how do you know how much to put out? Maybe preaching to the choir today, but as you talk to other fellow farmers, make sure that you're soil sampling consistently and continue to increase that the management of that, because there's a significant economic savings there as well as a water quality savings when you're not putting that much fertilizer out downstream. Second is the timing part of the 4 R's. So this is some of that edge of field data that Kevin is producing. This particular chart here is looking at subsurface total phosphorus concentrations. We think that it's common sense, don't apply your nutrients when you've got rain in the forecast, right? But how many of us have done that where it's, rain's coming, I got a little window here, I'm going to get it out there, I'm going to get it done. Well, what we see from this edge of field data is, again, warmer colors means more discharge. If you can wait, if you can apply your nutrients and get 5 days out and then not have a runoff event, you're going to keep that phosphorus in place. But how likely is that to have 5 days of no rain? That's pretty rare. How many of you guys think that the weather is changing? See some hands going up, right? This is some data that's pulled out of the Bowling Green Weather Station, and I'll point it out. It's in decades from 1900 up until 2017. Is this particular chart? So each bar is a decade. So you can see 1900 in 1-inch rainfall events. You can kind of see how it ebbs and flows over the course of the decades, right? 1.5 inches does the same thing. Was anybody alive in the 50s in here? Remember that it was that wet? So if we look at 2-inch, 2.5 inch, and 3-inch rainfall events, you can see a trend here, again, over the course of the decades, that we're getting spikes in these big, heavy rainfall events. Chris mentioned it. 70 to 90% of the nutrient loading is coming from about 10 rainfall events per year. This is a chart that Jordan just pulled together. He's looking at all the rainfall data across the state at these stations. And this is looking at, again, Bowling Green. This is the blue line. The blue line here is the decades of the 60s, the 70s, and the 80s in anything over 1 inch of rainfall. So that includes all the 3-inch rainfalls by month. So January here, December here. And you can see This is 20 right here, 20 events. You can see that trend over the decades there. This is the 90s, the 2000s, 2010s. And look at the trend. Yes, we're getting more, like we just talked about, but that weather pattern has shifted. It's shifted to the spring here, to March, April. We're getting more of those rain events. So maybe as you're thinking anecdotally in your own head, that makes sense. But what does that look like in reality? This is good. Wait for it. This is good. Here it comes. This is what it looks like on your farm field when we get those heavy rainfall events. And that's part of what the demonstration farms is about, is having that conversation with folks of all these great things that can be done, but when something like this happens, all that work is washed downstream. And that's the reality that we're up against. Again, it's not an excuse. We make our farms as resilient as possible, but what can we do to guard against things like that? This is one of our edge of field sites, and this was a little bit later that day when we had 4 inches of rain in a 24-hour period. Last thing on the 4 R's, and then I'll be done here, placement. This is a study, again, my job is to lift up what other people do. They're seeing about a 70% reduction in dissolved reactive phosphorus when you inject or till that fertilizer into the soil. And again, let's focus on injection so we don't have as much tillage going on out there. This is our Kellogg demonstration farm using his strip till rig. I usually have to explain what strip tillage is to the audience. I don't have to do that here today for you guys. But again, this is a large farming operation. They can spread that cost out on more acres. Maybe this is feasible for them to do. How do we accomplish that same task on the smaller farm acres that are out there? Uh-oh. Here we go. Maybe it's a toolbar like this. Does less disturbance. This is a 2510, I believe, John Deere 2510. How do we get that fertilizer placed below ground efficiently, cheaply, right? We talked about how there's a reason why people broadcast fertilizer. It's cheap, it's efficient. But as this more and more of this science comes out, how do we move towards this type of model? And then on the livestock side of things, this is the Saitler farm, a new toolbar that they got, again, injecting that manure below ground. If it's good for commercial fertilizer to be placed below ground, it's good for livestock manure to be placed below ground. And this is what we're going to be testing up against the strip till or the side dress application of manure on the edge of field site, getting that manure placed below the soil surface. So just to wrap up, again, the 4 R's is what I just touched on, what Chris touched on, is kind of the cornerstone of what we need to be thinking about from our farming operations. Developing that water plan for each one of your fields and thinking about how you can slow that water down and treat it, and then keeping that soil on your farm field. I will highlight events that we have coming up. April 26th, we're having a bus tour to all 3 demonstration farms. I know that's kind of getting into a bad time of the year for most farmers, but if it happens to be a rainy stretch and you want to come out and see things on foot, we try to bring in the experts from across all different aspects of what's going on out there to talk to farmers about what these practices are doing. So that's one. We'll have one in August as well. I'm going to hand out some information so you can contact me. If you want to bring a group up, by all means, that's what we do. I'll leave you with this. So how much fertilizer do you think we're losing, or nutrients, phosphorus nutrients, do you think we're losing on a per acre basis on average in the Western Lake Erie Basin? I'll say that again. How many pounds of phosphorus do you think we're losing on a per acre basis from the Western Lake Erie Basin? Half a pound? You guys are good. So on average, it's about a pound. Maybe a little bit less now as the data gets better. This is a pound of fertilizer. So what's the number that we're supposed to reduce that by? 40%. How much does a pound of fertilizer cost? Phosphorus. 50 cents, roughly? What's that? Asking. 50 cents. And we have to save 25 cents of that from going downstream to have a healthy lake. So I usually leave that with every audience that I talk to, especially the non-farm public, when they think that agriculture is the culprit. Why don't they just do this? Well, we're trying to save about 25 cents from going downstream. How much does that toolbar cost? 85. That's cheap, right? Yeah. How much does cover crops cost? 20, 30, 40 bucks an acre. How much do all these practices, there's a cost to those things to save about that much from going downstream on a per acre basis. That is not an excuse to not do things better. That is just the reality of things to think about from an agricultural perspective, and that's what we do with the demonstration farm. So I appreciate the opportunity, and if you have any questions, I'll be here along with Chris as well. So thank you.
Thanks, Aaron. That was, again, good information. And if I can challenge all of you here tonight, think about one thing you can do on your farm. We're not asking you to turn the Titanic around in a week, in a year. It's not going to happen. And that's part of the story that we need to tell to the non-farm public. We are trying, but it's going to take us a little time. So that being said, Mike Hannawald is going to give some more best management practices for us to try to learn about. He's a field agronomist and a precision farming specialist. He attended Ohio State University, where he earned a bachelor's degree in agronomy with a minor in ag business. He started his career with Beck's Hybrids as a precision farming field advisor, utilizing the Farm Server program. In 2017, he also took on the role of field agronomist for Michigan, Northern Ohio, and Northern Indiana. He's also a certified crop advisor and is actively involved in his family farm near Waterville, Ohio. Would you please welcome Mike Hannawald?
All right, thanks, Allison. Feel a lot of pressure after two great speakers like we just heard, but I'll do the best I can here. So Chris did a great job of sharing kind of the situation and where we're at. Then Aaron shared a lot of really good best management practices and some of the research that they're doing there. And so Rick asked me, when he invited me to come here tonight, he asked me to share some of the agronomics behind some of the 4Rs, why they work, and how can we make sure we're putting the right amount of phosphorus where we need it. And so that's kind of what we're going to talk about here. So kind of to set the stage, this is I found this data really interesting. So we talk about all these problems with having too much phosphorus and too much of it ending up in the wrong place and going downstream and ending up in the lake. But it's interesting, in 2015, just 4 years ago, the International Plant Nutrition Institute did a survey, and they looked at almost every soil testing lab across the country. And they looked at every single soil test that each of those labs processed and where those tests came from. And so in the state of Ohio, they found that of all the soil tests that were processed, that were sampled from Ohio, 48% of them were deficient in phosphorus. Pretty shocking. Almost half of our soils are deficient in phosphorus, and yet we have too much, right? And so I think that ties back to what Chris talked about, is where a lot of the runoff's coming from, a smaller percentage of the fields, and these fields or these areas of fields are not necessarily the problem. But it's important to understand that we can't quit fertilizing and can't quit spreading manure because we've got soils that need it, and it's just making sure we're putting it in the right place. What does that cost you if you're deficient in phosphorus? Well, 4 years ago in 2015, Ohio State did a study looking at soybean yields and found that on average, if your soils are deficient in phosphorus, you can expect a 7-bushel yield loss. So, pretty interesting. It can be pretty costly to not have enough. So we need to apply it, but how do we make sure we're putting it on the right fields, or more specifically in the right areas of fields? And so that's what we'll talk about here. There's the potassium numbers. You can see we're a little bit better in potassium. But the one really good piece of good news that came out of the Ohio State study was they found there's no yield difference between adequate and high soil test levels. And I'll talk about what that means in a minute, but as long as you're adequate, as long as you're above the critical level, you'll be able to produce a full crop and have maximum yield. You don't have to push that level higher because there's no benefit to doing that. And so that's good news on our acres that we have adequate levels. We don't have to spend the money on fertilizer, and then we can focus our dollars in investing in the right places where we really do need it. I want to start off talking about pH. So pH is something, we all know it's important to manage pH, but pH has a very specific impact on phosphorus. And if we manage our pH right, it can really help us manage our phosphorus. So the optimum pH ranges that we want to have for corn are 6 to 6.5. Soybeans like it just a little bit higher because the microbes in the soybean nodules like a little bit higher pH to produce that nitrogen for our soybean crop. And part of the reason that we like these pH ranges, 6 to 6.5, and preferably towards the top end of that, is because of this. So this chart is showing you all the essential nutrients that our plants have to have. And wherever you see a green bar, that means that that's the pH level at which that nutrient is available to the maximum potential. And so you can see here that between these two bars, so that's highlighting 6 and 7 pH, you can see between those two, almost every single one of these nutrients has green in there, meaning it's available. And so we want to keep that pH in the ideal range to keep those nutrients available. Now, a lot of us have seen these charts before, but from what I found, not a lot of farmers have a good understanding of why that is. So we're going to focus on phosphorus here. So phosphorus is the second bar, and you can see that phosphorus at a higher pH stays fairly available, but at a lower pH, it becomes unavailable. So I'm going to kind of explain how that works. And Rick asked me to explain this in about 5 minutes. So I'm going to try and condense 2 weeks worth of college lectures into 5 minutes, and I'm going to do it using poly fertilizer tanks. So we all know what these are. We all probably have them on our farm, right? And so I want you to imagine for a minute 4 of these poly fertilizer tanks all lined up just like that. All right? And we're going to set those 4 tanks on a teeter-totter or a seesaw like you'd see on a playground, right? And so we're going to line up all those tanks like that. And then we're going to go ahead and fill the tanks. So each tank represents a different form of phosphorus that exists in the soil. So we have iron phosphates, we have aluminum phosphates, we have calcium phosphates, and then the last one is available phosphorus. And that's the one that we care the most about. All right, so phosphorus exists in all 4 of these forms. Now, 3 of the 4, iron, aluminum, and calcium, are locked up, tied up, inaccessible by plants, and not detectable by our standard soil tests. And so we have to remember that they're there, but they don't play a big role in our management. The key is the available phosphorus, because that's what's available to our crops, and that's what our soil tests detect. Now, anytime you're setting up these fertilizer tanks, you have to have some plumbing, right, to be able to move product from one tank to another. And so we're going to go ahead and plumb these tanks. Now, what you see here, these big thick bars, those are like, I want you to think of those as a 3-inch line. You can move a lot of product in a hurry through a 3-inch line, right? This one here is a little bit narrower, so that's kind of like a 2-inch line. So you can't move quite as much through a 2-inch line, but you can still move a decent amount. These 2 skinny bars here, though, those I want you to think of as garden hoses, all right? Can't move a whole lot real fast through a garden hose, all right? Now, these lines, this plumbing, they have check valves in them. They can only flow one way, all right? So that's what those arrows indicate, is what direction product can flow through each size of line. And so that's kind of explaining how those chemical reactions happen that change phosphorus from one form to another, and the rate at which those can happen. I know this isn't a system that any farmer would design, but this is the system Mother Nature gave us, and that's how those reactions work. Now, how do we fill the tanks? Well, we can spread manure or fertilizer. So manure contains a lot of different complex compounds in manure, and phosphorus comes in many forms. And so when we spread manure, we're going to be adding a little bit to all 4 of those tanks. That's why if you ever look at a manure analysis from a testing lab, it says how much is available the first year versus how much is totally available. What's available the first year comes into this tank, and what's not available yet is going to come into those other tanks. Fertilizer, for the most part, at the time that we spread it, is fairly available, and so when we spread fertilizer, we're pretty much just going into this tank. And how do we get it out of the system? Well, the available phosphorus is what feeds our crop. So this is kind of setting up here how the soil works and how these reactions happen in our soil. So now we're going to start to adjust the pH and see what happens. So what happens if we get a high pH? So you can see we're starting off here, we're perfectly balanced at 6.5, which is kind of the ideal pH that we just highlighted a little bit ago. Well, what happens if we get too high and we go to 7? All right, so it's like tipping all those tanks. And so everything's naturally going to flow this direction, right? It's going to flow downhill. Now, these 2 tanks aren't going to change a whole lot because we've just got garden hoses here, so it'll trickle over a little bit, but it's not going to move very much. The available is going to tie up as calcium phosphate because we've got a big 3-inch line, and so some of it's going to move that way. But it's not that big of a deal because as we feed our crops and draw this available down, it will move back through that 2-inch line. And so you can, it's not going to move back quite as fast, but it'll move back pretty quick. And so, a high pH is it's not a good thing overall, but it's not terrible when it comes to phosphorus management. The real problem comes when you get your pH too low. And so we're going to tip it the other way. So what if our pH goes all the way down to 5? All right? Now it's important to remember pH is not a linear scale, so it's a logarithmic scale, which means that 6 is 10 times as acidic as 7, and 5 is 10 times as acidic as 6. So that if you do the math, that would mean that 5 is 100 times more acidic than 7. So it's pretty severe when we get down to a 5. And so you can see what happens. We tip this all the way down here, and we've got 2 great big 3-inch lines running this direction, and we're going to pretty well drain that available phosphorus tank, and it's going to tie up into these iron and aluminum phosphate forms. Now, I've gotten the question from farmers. They say, okay, money's tight right now. Looking at corn prices starting with a 3, soybean prices starting with an 8. Maybe now's not the best time to spend a lot of money on lime. What happens, how much is it going to hurt me if I've got a soil test calling for lime and I just decide to put it off for a couple years? Well, what happens is your phosphorus is going to tie up pretty quickly, and then your soil test, you can go out and soil test this, and the soil test only sees this tank, and it's going to say you're pretty low here in this tank. So what do? You do the math, you follow your tri-state recommendations, you go out and spread phosphorus, all right, across the field, and you're going to have to spread a bunch to be able, because you've got a low soil test level. Well, you're going to start filling this tank. The problem is you still have a 3-inch line that's going to drain it off. And so it's going to, the fertilizer that you go spread, not only is that opening you up to some risk for some runoff in the time that you're spreading it, but most of that fertilizer is going to get tied up right away and isn't even going to be able to be used by the plants that you have. And so you really don't want to avoid getting into this situation. The other thing is that the penalty of being in this situation is not only extra fertilizer costs, but it's also the long-term effects. So say, okay, we delay it a year, we get into this situation, but then we're going to go back and spread the lime next year. Well, we spread the lime, we get our pH balanced again, but look what happened to the tanks. The tanks are still way out of balance. These 3-inch lines tied this phosphorus up really quick, but we only have garden hoses to unlock it. And so it's going to take a long time for that to become available. And so those consequences are pretty severe if you let your pH get out of balance. And so ultimately, we want to keep up on our lime applications, make sure that we're doing that and investing the time, money, and effort to get the lime spread so that we can keep things in balance, make sure that we have as much available as what we can. And if we have as much available as what we can, that's less that we have to go out and apply. And if we're spending less time applying it and we're applying less fertilizer, that's less risk of losing it. And Chris talked about, remember how he took that application window and we're making it narrower and narrower? If there's less we have to apply, that's less we have to get done in that narrow window. Lime, we can be pretty flexible when we apply lime. It's fairly stable and it's not really gonna go anywhere. It's rock, ground up rock is what we're spreading on the field. And so we've got usually some more time to get lime spread timely than what we do getting fertilizer. So if we focus on lime and maintaining our pH, we're going to have to, in the long term, spread less fertilizer, and it'll be better for our bottom line and also better for the lake. And I know a lot of you already work with Rick and Allison and doing soil testing and recommendations, and they've got you doing this, and a lot of you are doing this really well. They're just kind of emphasizing the importance of not just looking at phosphorus, but looking at lime and pH and how that can impact your phosphorus. All right, another thing I want to talk about is, so we're keeping our pH in line, but now how do we decide how much fertilizer to go out and spread? And so one method is removal rates. So we know that how much of a bushel of corn consists of phosphorus and how much of a bushel of beans consists of phosphorus. And so we can calculate what we're removing, what we haul to the elevator and sell, and then, we should replace that, right? In theory, that makes a lot of sense. And so if we're growing a 200 bushel corn crop, we can go spread 131 pounds of MAP, and that'll replace all the phosphorus that 200 bushel corn crop takes away. The problem is that our soils don't quite work like a checkbook. And I've got an illustration here to kind of demonstrate that. So this comes from a PFR study that Bex did. So PFR is Practical Farm Research. This particular study was done in our Southern Indiana PFR location from 2008 to 2012. We actually don't have that location anymore. We've since moved it down to Henderson, Kentucky. But back then we did have this location. It was a 5-year study. It was a corn-soybean rotation, so in 2008, 2010, 2012, we had corn, and in 9 and 11, we grew soybeans. Now, the purpose of the study was to test crop response to different rates of fertilizer. I'm not going to talk about that. I'm going to talk about how did the soil test change over time in this study. So the fall of 2007, before they started the study, they went out and soil tested each plot. And so what you've got here, this is the soil test right here where we started. So we started just under 100 pounds per acre of phosphorus was what that tested the fall of 2007. Now this particular plot, they did not apply any fertilizer over all 5 years of the study. And so what I did was I just did the math and I looked at what the yield was in this plot each year and just multiplied the yield by the crop removal rates, and you could figure out how much phosphorus we took off that plot every year. And so doing that, you can see that our phosphorus level should have trended downward pretty quickly because we're not replacing it, we're not spreading any fertilizer, and in 2011 we should have plain run out of phosphorus. But yet in 2012 we still grew corn. The corn wasn't very good, but that was because of a drought, not because it was short on phosphorus. All right, so how did we grow corn with no phosphorus? You can't do that, right? That's because it wasn't all gone. So fall of 12, after they harvested the corn that year, they went and pulled a soil sample and found out that there was over 40 pounds per acre of phosphorus left in the field. But according to those removal rates, should have all been gone. Why is that? All right, I see someone waving back and forth. It's the tanks, right? So think back to our tank situation. If we are draining this tank and not putting anything else in it, what's going to happen to the other tanks? It's going to move. And that phosphorus is slowly going to become available. Yeah, there's only garden hoses here moving, but over a 5-year period, that garden hose will move a lot of product. And so, yeah, we were still depleting. You know, when you look at this, we still drained our phosphorus levels, drew them down, but we didn't draw them down near as much as what we thought we were going to. And so, because of those tanks and because of those reactions and that phosphorus locking up and unlocking, it doesn't work like a checkbook. It's not just measure the amount of fertilizer that I'm withdrawing from my account and then make deposits to offset that. You've got to factor into what the soil's doing. And so that's where regular soil testing is really important, because regular soil testing lets you monitor what are those levels so that you're measuring what's in this tank. And if you check up every 2, 3, 4 years, whatever your program is, check up on what's in this tank. That will help you keep track of what moved from these other tanks into this one. And so keeping up on your lime, keeping your pH in place, and then soil testing regularly to check up on what's in this tank will help you make sure that you're only putting the fertilizer where you need it. And that helps not only your bottom line to help you be more profitable by cutting your costs, but that also helps the lake because that's less risk of that fertilizer running off before it gets incorporated into the soil and utilized by the crop. So, what's kind of the philosophy behind how our soil test levels work? So this is kind of the way that the tri-state, which is kind of the governing recommendations, this is how they look at it. So we've got high soil test ranges, so that means there's more than enough nutrients present. We don't need to spread any fertilizer or manure. We've got adequate. This means that we've got enough nutrients to reach our maximum yield potential, but we might still want to apply to maintain those nutrient levels. And then we've got deficient. And so if we have soils that are deficient, that means that we are going to lose yield if we don't apply some fertilizer there. So in this high soil test, the strategy is to save our money, not spread anything there. The deficient, that's where we don't want to cut our costs. We want to get those applications made so that we're producing the maximum yield that we can. And so, you know, kind of taking that strategy, we want to live somewhere in this adequate range. The best place to be, in my opinion, is right at the top of the adequate range. There's no benefit to go up into the high. That Ohio State study done a couple years ago, you know, proved that we're not going to gain any yield going up here. But if we manage at the upper end, this gives us a lot of flexibility because we will always have enough to produce a crop. And so if you do that, you may not have to apply fertilizer every single year. And so we're talking about narrowing that window of application. Well, what happens when we get that really wet spring and we can't do anything until the third week of May, and at that point we just need to get out and plant, right? And you've got a narrow window to get stuff done and you've got a rainstorm coming. Do you really want to be spreading fertilizer? You should probably be focused on planting, right? And you don't want to be spreading fertilizer right ahead of that rain. Aaron showed that research that as long as we can get 4 or 5 days with no rain after we spread, we've got a lot better chance of not losing it. Well, if you're living up here and you get pressed and can't spread fertilizer, it's okay. You can wait till next year because your soil's going to provide everything you need for that year. If you have the right window and the good opportunity and the good weather to get it done, go ahead and get it done. And as long as you're living in this range, you know, it'll incorporate into the soil and it'll be available for the next crop. But if we focus on maintaining right around here, that gives us a lot more comfort and a lot more flexibility to be able to get those applications made at the right time and not be pressed and feel tempted to do something that we probably shouldn't be out doing. Now, unfortunately, not every farm works that way, and so sometimes if we've got a short-term rental agreement or we've got ground owned by a developer that we could end up and lose someday to be built up to houses or something, we don't want to leave extra fertilizer there. We can manage right down to this deficient line, and we won't, as long as we stay above the red, we're not going to lose any yield. And so you can live down here if you have to, but ideally we want to operate up here. And I know I've met with a lot of you in the room, and I know most of you here are working with Rick and Allison and Eric, and they're all helping you do that, focusing on, you know, living up there to give you that flexibility. So Eric and I were just talking, standing over there at the side, and Eric had mentioned, you know, last week a lot of people were out spreading fertilizer, but he wasn't because he knew that it wasn't the right time, and they're calling for rain. And, you know, we got the rain, but it's because of this good management that a lot of you are doing that you're able to have that comfort of not feeling like you have to be out there when the time's not right. So specifically for soil tests, what are those numbers? I wanted to highlight this just because these numbers have just recently been updated. So previously, the tri-state recommendations from Ohio State operated on the Bray P1 test. That's an older test. I don't know of any soil test labs that still use that test. A lot of labs still report with those numbers from the Bray test. They just convert and they tell you what the Bray equivalent is, but very few soil testing labs are using that anymore. Most labs are moving to the Malick 3 test, and so that's where Ohio State just kind of revised the tri-state to fit the Malick 3, since that's what most labs are using. And so if your results come back as a Malick 3, 20 to 40 parts per million is where you want to live. That's that adequate range. And if you keep it in that range, you'll be in pretty good shape. There's no benefit to going over 40, so save your money and don't spread the fertilizer. If your lab still reports in Bray P1, 15 to 30 is the range that you want to operate there. So I just wanted to show those numbers since they have changed recently with Ohio State revising to update for how labs are actually doing the test. So take-home points to kind of wrap up. Number one, maintain your pH by applying lime as you need it to maximize the availability of phosphorus in the soil, and then minimize the need to be out spreading where you don't need it. Regularly soil test to observe the trends over time and be able to account for the unlocking of that tied up phosphorus and be able to measure that and use that to your advantage rather than risk over applying because you don't know how much of that is available. Fertilize or apply manure as needed when the soil test levels are low. And so make sure that you're getting it out there, but just where you need it. One thing that Rick does a really good job of is kind of coordinating manure applications, so where manure can be brought in from other areas and spread. If you need the phosphorus, manure is one of the best sources because it brings in organic matter, it builds up the health of your soil, and it's also diverting manure from potentially being applied to other fields that don't need it. And so if you guys can utilize it, it's good for you and good for your fields. Then also, it's not being placed in other fields where it could be problematic. And that's something that's pretty neat, how you guys can work together and work with Rick and Eric to get that done. There's no benefit to applying phosphorus if you're above the critical level. So if you're above that red zone that I talked about, you're not going to increase your yield. If you're in that yellow zone, you want to apply just enough to make sure you don't drop into the red zone, but there's no benefit going up into the green. And then last, make sure that you maintain adequate levels of phosphorus because it gives you more flexibility in getting fertilizer applied so that you're applying it, it's easier to get it done in those narrower windows and less risk of it ending up someplace where we don't want it. So with that, that wraps up all I've got to share. I'll turn it back over to Allison.
Hand. We're going to bring Aaron and Mike and Chris back up for questions. If it's past your bedtime and you want to head home, it's past my bedtime, you may do that. This would be a good time to do that right now. One thing we're going to do real quick while these guys get set up is we're going to ask Susan, I'm putting you on the spot, I apologize, and Craig to come up and talk about, for just a couple minutes, some interesting things that are going on at the State House that are going to impact water quality in the state. So Craig and Susan, I'm going to turn it over to you for a couple minutes, and you can talk about the State House, Governor DeWine, and what's happening to help us out.
Thank you. Thank you, Susan. Okay. All right. I'll stand real close to you here. Well, good evening, everybody. I'm Craig Riedel. For those of you who don't know who I am, and I think there's probably quite a few of you, I'm the state representative for Ohio's 82nd House District, and I represent Defiance, Paulding, and Van Wert counties, as well as the northwest corner of Algal County, and that's why I'm here. And so we're actually in Susan's part of Algal County that she represents, and I'm in my second term, so I'm considered a sophomore. I live in Defiance. I grew up on a farm in Seneca County. But this is a tough act to follow here, that's for sure. And what I thought I would just mention, there's a couple, a few bits of legislation that I know in my first term as a state representative, we passed a bill right at the end of last year. It had been fall of 2018 that you might be familiar with. It's labeled Senate Bill 299, and what that bill does is it appropriated about $36 million for water quality issues around Ohio. And I know some of the highlights of that bill, and I reckon, Chris, you're probably pretty familiar with it. But one aspect in particular that I thought was very useful is that, and you maybe already know this, that there's money that was allocated to the county soil and water conservation districts to help you all with your nutrient management plans and your soil testing to help defer those costs. So that was some legislation that, like I mentioned, it went quite a bit, and some of that money went up to the Sea Grant for research there, so Chris got some of that. I know some of that money also went to figuring out ways how we can drench the lake and make use of that sediment, or if we can figure that out, someone's going to be a multi-millionaire. And and currently, that was in the last GA. That was probably the most significant bill I can think of that we worked on in the last General Assembly. Currently, we just began the current General Assembly, and you might be aware we're very focused right now on the transportation budget. That's got everybody's focus at the moment. We hope to have that wrapped up here by the end of March. And obviously that's very important to you all because we've got to have good roads and infrastructure here for you all to do your job. And we'll get that accomplished here. That's going to be about an $8 billion budget to supplement ODOT and local government for the next 2 years. Friday, we're supposed to get the operating budget from Governor DeWine, and that's the budget that you really hear about most often. That's the budget that runs the state of Ohio for 2 years. That's Medicaid, education, law enforcement, and it's about a $65 billion budget for 2 years. But what I wanted to highlight was, and you may have heard the governor, our new governor, who I really like, and I think he's going to do a terrific job. But he's mentioned often when he was campaigning, and since he's become governor, he's mentioned how he wants to put a high priority on addressing water quality issues throughout Ohio, not just the Western Lake Erie water basin, but all of Ohio. And there was a bill, I think I'm trying to remember in the last General Assembly if it did get any hearings, but it was introduced by Randy Gardner, a senator up in Bowling Green, that would have, and it didn't get accomplished, but it would have appropriated $1 billion over a 10-year period. We'd have sold bonds, but that money would be used to help all of us as Ohioans address water quality issues. It died in the last General Assembly, but Governor DeWine has talked about that bill. He was a big fan of that, and I'm anxious to see what his budget. We'll have it on Friday, but I won't be surprised if he has that bill inside of this operating budget, because, like I said, he was a real supporter of that. So $1 billion that would be appropriated, and it'd be spread out over 10 years. And again, all of that money would be used towards improving and helping and finding ways to improve water quality throughout Ohio. And one last thought, and Susan, I'm sorry, I know I'm doing all the talking here, but I just want you all to know that the legislature is very, very supportive of the farming community, and we're going to do everything we can to work right side by side beside you, and we'll figure this out together. So appreciate you being here tonight. Thank you.
Thanks, Craig. And hi, everyone. My name is Susan Manchester. I represent the 84th House District, which covers this part of Auglaize County, parts of Shelby and Darke counties, and all of Mercer County. So with Grand Lake St. Mary's being in my district, obviously water quality is at the top of my agenda. And I will tell you, I serve on the House Agriculture Committee, and in our first introductory meeting, water quality was the #1 item on everyone's list. So this is something that's gaining a lot of traction and attention in Columbus, and I'm just really grateful for all of you being here tonight and for the work of these three gentlemen. I feel much more informed after listening to your presentations, and I'm very grateful for you taking the time to bring all this information to us as policymakers, because as Craig said, we are waiting with bated breath to see what Governor DeWine proposes in his budget on Friday. He's obviously made water quality and addressing the issues in the Lake Erie watershed and across the state his priority, and so I'm hopeful that as the legislature moves through the budget process, we'll be able to get the resources where we need them so that you guys can continue to do the great work that you do. So again, thank you, and please don't be a stranger. I know that a lot of you live in my district or farm in my district, so I encourage you, please call me up. If you don't have my number, you can always ask my dad. And again, if you're ever in Columbus, feel free to visit anytime. So thank you so much.
Hey, man. How are you doing? It's good to see you.
Directing all questions to you, right?
That's right. I'll start with a question. How about, is this on? For Chris. We talked a lot about phosphorus tonight, but can you explain nitrogen and the importance of that in the water quality issues that we have in Lake Erie?
Great, thanks. So yes, we often talked about phosphorus because it's always mentioned in the media, but what we've found through our research is that nitrogen drives toxicity. So you need the phosphorus to get these organisms to grow, but once they grow, to build that toxic molecule, it's made up of a lot of nitrogen. And so nitrogen can impact toxicity. The other thing we need to remember is that 2/3 of the state drains into the Ohio River, which ultimately ends up in the Gulf. In freshwater systems, phosphorus drives the blooms. In marine systems, nitrogen drives the blooms. So all the nitrogen that's in the Ohio River can cause toxicity, but when it ultimately gets to the Gulf of Mexico, it's driving the same blooms that we're concerned with in our freshwater systems. Now, thankfully, as we're shooting to lower the phosphorus, a lot of the BMPs that we recommend also work for nitrogen. But don't be surprised if we start hearing some discussion on concentrating more on nitrogen and nitrogen impacts. Thanks for that.
Chris? So we talked about the 4 R's and not spreading fertilizer on frozen ground and on and on and on, and we still see people, I mentioned to you at the CLM, we had a farmer give me a soil test that read 800 parts per million of phosphate, and the local retailer was still recommending 250 pounds of that. So with the 4 Rs, isn't there some way that we can have somebody with the state do more going in and doing inspections and stuff to keep that from happening?
I think all three of us can answer this. I think regs are always a tool in the toolbox, but I come from a research, education, and outreach background, and so I'm happy to drive here and be here and talk about the importance of soil testing and to follow the tri-state fertilizer recommendations. I mean, I think that's what we have to lead with. But just like in businesses, there is water cooler talk within the ag community. And so be that individual that soil tests, follows tri-state fertilizer recommendation, and has the same, if not better, yield than your neighbor. And let them continue to pay the fertilizer bill that you're not paying. I mean, a lot of this is, you know, I'm from a competitive family. A lot of this is in that space. So my recommendation is be part of the solution. But please know that behind this reduction in 60 or 40% of the phosphorus, there was a timeline set for that. We wanted a 40% reduction by 2025. So again, I'm not an advocate of pulling out rules and regs right out of the gate. Let's talk about education and things like that. But if we get to 2025 and we haven't fixed this problem, that's when you need to start, you know, that's when these things might be pulled and these levers might be pulled. So I'm an advocate of being proactive rather than reactive because of policy. And so that's where I'll leave it.
And I'll just piggyback off that, and if Mark wants to jump up and explain what he does, but to that point, the 4R retailer certification program is out there that, how many retailers across the state are certified now? 52?
In the Western Lake Area Basin, about 40% of the acres in the Western Lake Area Basin are certified. So these dealers and crop consultants agree to voluntarily be audited by outside auditors. They're independent, and that they follow tri-states. And I know exactly what you're talking about. I've seen them. I mean, I don't know who it is, but that is a voluntary program that's gaining traction, and that does address that issue. Voluntary.
But, you know, a little bit of peer pressure of, you know, as the neighboring businesses start to be certified and shouldn't be spreading on frozen, snow-covered ground and shouldn't be recommending nutrient applications on those fields that are above tri-state. That's the overall goal, so that we can avoid having the regulatory punch come in and say, you're not going to, we're going to handle it ourselves.
And I'll just add real quick, I'm a farmer too, and I know from a farmer's perspective, I'd much rather just do this myself than be told I have to, and I think all of us in the room would probably feel that same way. So if we can start implementing these things that, you know, almost there, yeah, Chris talked about there's some things that cost money out there, and if, you know, and the representatives just talked about how the government, you know, is going to be allocating some funding to help us out with those, but the things that make sense that we can do now and save ourselves some money, let's just start doing those on our own, and a lot of you already are, so keep up the good work. So, who else has a question?
First of all, I want to comment on each of the speakers for staying within your area of expertise. You know, agronomist, best management practice, aquatic biologist, environmental scientist. I appreciate it when I learn about things from somebody who knows that specific area. So hats off to you guys for doing that. I think so often we hear things from those who aren't within that profession about how it works. My question to all three of you is this 40% reduction, one, has it been defined how that will actually play itself out? How will it be measured? Will it be measured at water bill based on a gauge that goes down through there? Will it be an edge of field in which we're looking at, you know, 1 pound of fertilizer, and will that edge of field be the point of measure? How will that 40% be measured?
So given it's not cheap to monitor, Heidelberg University has multi-millions of dollars to do what they do. When we do our forecast to say how big the bloom is going to be in a given summer, and it's that window of how much phosphorus came from 1 March to the end of July, It is at Waterville that data for that model. But if you saw the executive order that ran through, K6 administration, the reason why those 8 were picked is because we have monitoring stations throughout. And so when I say 40% reduction, we actually know what that looks like from a concentration of phosphorus. So if I go out and take a water sample and measure how much is there, we know what value that needs to be. So 40% is the way we're communicating it to stakeholders. We know what that value is. We know which streams within the Maumee or the Western Basin are 2 times that value, 3 times that value. So we have a monitoring network pretty far. Edge of field, best way to do it, because then you can see, here's how I changed, here's the resulting reduction. But to maintain one of those stations, you'll know better on this, it's about $250,000 for a 3 or 4 year monitoring station, or is that high?
$30,000 per box on each site. So, there's 4 boxes on one site. That's $120,000 roughly to maintain that one site. So he's got 20 of those across the state.
So to expect that level of detail at the edge of field, no. But what we need to do is use his information saying, you do this, I'm measuring this. That's what the demo farms are doing, is giving the proof is in the pudding for the demonstration for the practices. But the measuring will be happening through our in-river station.
And from the agronomists and others, is that a reasonable way? Taking a grab sample from a river stream that will apply to all of those up in the watershed? How reflective of that is that number?
I guess as an agronomist, I focus on what helps us increase yield and what doesn't help us increase yield. And that's where, I look at, like Aaron's research with the edge of field is to tell us what practices are going to get us the biggest benefit, and then look at, okay, how do we take those and implement those? And so where do cover crops fit into a system? If cover crops help, how do we fit that into the cropping system? So that's kind of where I'm at, but I agree with Chris that ultimately, we need to reduce 40% reduction across the whole watershed. Some fields are going to have to reduce by more than 40% to get there, and others don't have to reduce that much. And so that's, I guess, my role as the agronomist is looking at the research that, people like these guys here come up with, and then helping the farmers. How do we fit that into our system and still grow corn and soybeans and wheat profitably? So.
You're going to run into a problem like from the executive order. There were 3 rivers called out that were top 12, which means about 50,000 acres. So that stream device is telling you the concentration, that's coming from 50,000 acres. So that's why we need this group to know, am I individually of those $50,000 am I making a change? And the problem is it's got to be collective effort, because you can do everything you want, but if your neighbors upstream aren't buying it or aren't doing it, you're gonna be lumped into that sub-water. And that's why it has to be us. Not just you, it has to be us. To at least a minimum soil test. And if you are at 50 parts per million, or 40, you got 50 to the top. If you're there, you're doing it. And keep doing it. And show them that your yield is where it needs to be, and that your pocketbook looks good, and peer pressure, that kind of.
On all those demos that you're doing and stuff like that, what kind of cover crops are you using, and are you using cocktails or monocultures and things like that? What are you doing as far as that angle on the demo plots that you're doing?
Yeah, on our specific demonstration farms, so we're into year 4, but the farmer is actually only into year 3, moving into year 4th cropping season, I guess. So they have done a variety of things, from straight cereal rye to a blend of oats and crimson clover. We haven't done anything on the edge of field monitoring sites yet to actually start to measure that quantitative loss. One of the slides I didn't show was, again, I'm showing what Kevin's doing on all his other sites. They did a cereal rye plot using liquid dairy manure, and they did a 7,000 gallon rate and a 14,000 gallon rate, and then no application obviously on the other side. They applied that cereal rye into standing corn and measured, and they had a 90% reduction in nitrate from that field that had a cover crop in it, but they had no measurable difference in phosphorus leaving that field on both sites that they did that. So cover crops have a lot of benefits from a soil health perspective, tying up other nutrients. But from a phosphorus, right now it looks like maybe that direct benefit from the phosphorus leaving the field may not correlate out. Now, that's early study that could, as this goes on for the next couple of years, that may change a little bit, but just implemented this practice and this is what left the field. Phosphorus wasn't directly impacted.
Along the same lines of water management, we are showing that the water coming off for a year doesn't change, but when it comes off the field, does. And so it's holding that water in the fields during those times when you don't want the runoff. So soil health benefit and water management benefit, not
What
all.
I was really concerned was, well, actually, not concerned, but was thinking like, you're saying zero rye and what's in clover and stuff like that, but I'm talking like a cotton mix that has like 8 or 10 things in it. You'd mentioned on that stapler farms, that stapler, that you were going to have a wheat crop and go to the corn next year. Well, why couldn't you put like an 8 or 10 way mix after that wheat crop and then put all that manure out there that it would hold all time?
And I didn't mention that. They are going to do that. They're doing about, I think, a 6 or 7 way mix after that wheat comes off, and we'll apply manure on top of, I think they'll put it down first, then plant into it. I think is how they'll probably do it. But then, that will be on the edge of field monitoring. We will be able to tell the difference of what leaves those fields. This guy in the back, who's first?
So, concerned with water management, it's always been a source of pride to be able to get rid of water. Now we're asking, we need to slow that up. Are there cost incentives to like help farmers putting in tile gates and that sort of thing? I haven't heard that much talk about that, because it's the big rain events that's really given us a lot of headache.
Yeah. So the drainage water management structures, if you're all familiar with those, that kind of square box that sits on the tile that you can move the boards up and down. There are NRCS cost share programs. There was, I think, a Department of Agriculture did some. I don't know if they still have those available or not, grants. Those cost about $1,000 to $2,000 for one of those structures, but they only fit in certain landscapes. You start to get a lot of topography changes, then they may not fit very well as you come further south from up in the western basin. But the reality is that we lose about 70% of our drainage water during the non-growing season. So, we're coming up to the growing season now, but all winter here, all that water's been leaving the tile system when you don't really need it to be leaving the system. So again, as we think about combination of practices, if it fits your operation, that's one for a relatively cheap cost you could implement and save a lot of water from leaving that field when you don't need it to be.
I was just wondering, have you studied the amount of phosphorus that you do your edge-field studies that's coming out of tile versus what would come over the surface? Because it seemed that the surface would be the worst of the two stories.
So how many of you think that the surface would discharge more phosphorus than the subsurface tile? How many think subsurface discharges more? Come on, that was like 5 hands.
How many of you are asleep?
So the question, if you didn't hear, was where does more phosphorus come from? From what they're saying, what they're seeing is that when we have a heavy rainfall event, more phosphorus does come off the surface. It's that concentration, that concentrated flow. The problem is that tile is running throughout the course of the year. That load, the quantity over the course of a year, is more coming out of the drainage tile. So it's a little bit of it's both. You got to be able to manage both. Now, you get a 3-inch rainfall event, there's not a lot you can do to hold that back. But if you can improve your soil health with cover crops and no-till, get that water to filter into the soil and absorb, you can hold a little bit more there. You can put drainage stops in to slow that tile water down, filter strips, a wetland if it fits. All those different things, you got to think about your own farming operation and where they fit, but it's a double-edged sword.
That's implying that the water table has got phosphorus in it, because all the water in the tile comes up from the bottom, virtually. So that means that phosphorus, some of that phosphorus is actually in our water table, because that's the way you fill the tile. You don't fill the bottom on the top, you put it in the bottom.
Yeah. No, but so when you get macropores, if you've got oxygenated soils, it'll hold that phosphorus. So when we get released, like when I talk about Lake Erie and how much goes from the bottom of Lake Erie to the top, if you go anoxic without oxygen, that phosphorus is taken off. So that plays a role into it, how much, what your oxygen levels within the soils and your macropores and micropores. So there's a whole level. That was, for me, when I was in college, it was like the decade of the brain. We knew nothing about how the brain worked and memories. Right now, I think we need to be in the decade of soil health. We use that word, but we don't really know what it means because it includes a physical component, a chemical component, and a biological component, and we have not wrapped our head fully around that mess. And so we need a lot of work in there. So as you're saying about, is phosphorus coming off the surface? Is it in the tiles? Where is it being held? Where is it being leached from? There's a whole soil health issue that we've got to wrap our brains around.
Just to add to that, the cover crop study that I mentioned earlier, where the phosphorus loss wasn't really noticeable, that the field that had cover crops on it discharged about 2.5 inches less of water because it was held up, whether it was in the cover crop, the soil health, whatever it was. So, I mean, that's the component there that can help reduce water.
And I think, don't quote me on this number, but I think for every 1% increase in organic matter, you hold 3/4 inch of rainfall. Right? So that's why, though, the issue is like, it's going to take you 6 years to hold that water because you need time to build up that organic matter to get that holding capacity. So things like that's where we got to be thinking critical about this. If we're going to pay for incentivized cover crops, only pay for the first 7 years because after that, now they got the soil they want, just maintain it. So there's a point where you got to incentivize it in the early and then maybe you lay off that incentive once that cover crop is paying its dividend back to that farmer. We've got to have these little nuances and additive approaches here.
Question for Chris. About 1/4 to 1/3 of the watershed of the Western Basin of Lake Erie is outside of Ohio, Indiana, and Michigan. It looks like Ohio is way ahead of those two states because today manure and phosphate fertilizers can be spread on frozen ground, can be spread ahead of a rain, and issues like that. Now, Michigan would be one of the 14 sea grant states. Indiana wouldn't be. But what progress are those two states making in helping to solve Lake Erie's problem? Because I can see where every farmer in Ohio can do everything exactly right. And Indiana, not to pick on, I hope nobody's here from Indiana, Michigan, but I don't care about Michigan, but Indiana. But seriously, what is going on in those two states? Because I get the sense that not nearly enough is going.
Not from a regulatory standpoint. They don't have their Senate Bill 150 and their Senate Bill 1. So that was great that, that Ohio did that. Now, again, I pointed out earlier, Senate Bill's also got some problems because if you're going to say no rain, no application of fertilizer when the rain is in the forecast, well, if you had dry soils, maybe we should have opened that. So there are some hiccups within there. What I will tell you is those gauging stations that we talked about earlier, like where we know the phosphorus is coming from, that question, we have put a gauge on the St. Joe's as it leaves Ohio and goes into the other state. Same thing with the St. Mary's. As it leaves Ohio, we know exactly how much phosphorus in the concentration is as they leave Ohio. And then we have a gauge right on the Maumee as it comes back into Ohio. We know what we're giving them, and we know what's coming back. And right now, it's not worse than Ohio, but it's not any better than Ohio. Actually, I would argue that it's probably a little worse than Ohio. If you've been in that area between, like, around Fort Wayne and that area, there is still a lot of farming right up to the fields. There's a lot of Amish farming where they just don't have the techniques and the ability to put things in place. So, but they're at the table. There is a Michigan Sea Grant. There is actually an Indiana-Illinois Sea Grant. It's joint because they touch Lake Michigan. So I do get to work with my colleagues on that all the time. But again, I was mentioning this with Jordan. I don't know if he's still here. Toledo was a horrible, horrible event. You don't want to live in this amazing country we live in and not be able to turn on your faucets. But you don't want to waste a good catastrophe. And what that did for us is it spurred money and investment and people coming to the table. I have never seen in my academic career the amount of communication that's going on right now. Across state agencies, they're talking more than they ever have before. And then between the agencies and the academics. Before, the agencies would have never said, we're going to go to these brainiac weirdos in the universities and ask them for help, but it's happening now. And so Ohio's in a good place just because Lake Erie is so important to us, and we're right in that epicenter. So I think they're catching up. They're maybe not as far ahead as we are. Same thing with Canada. We have a lot of federal investment and things like that coming into the region because we have a population around here. The population in Canada just doesn't have the tax base or the investment right now, but they're catching up.
Is there any research being done as far as stabilizing the phosphorus, kind of like they did with the nitrogen and NSER? Is there any research or anything being done as far as something like that to benefit phosphorus or leaving the soil once it's in it?
I haven't come across anything specifically to stabilize it from leaving. There's products that look at trying to make some of those locked up forms more available, but that doesn't help our problem here. One thing I'll tell you, so, Chris mentioned in his presentation that the university and extension used to tell us that, you can use your soil like a bank and phosphorus doesn't go anywhere. And that's not entirely false. So phosphorus exists in different forms. You saw that up there. Those locked up forms of phosphorus, they're not what we're concerned about. They're not going anywhere. If it's locked up as aluminum, iron, or calcium phosphate, it's fairly stable. And then a lot of the available phosphorus is fairly stable in the soil too. So once the phosphorus enters the soil and incorporates with the soil, it goes through a process called adsorption. That's not absorb like A-B-S-O-R-B, it's A-D-S-O-R-B. And I'd have to go dig out my soil chemistry textbook to give you the exact explanation of how it works. But it goes through that adsorption process. And once that happens, it's tied to the soil. It's not going anywhere. And that can be a challenge for our plants because phosphorus doesn't move in the soil like nitrogen does. And so our plant roots have to grow to it and find it rather than it moving into the roots. But so once that happens, as long as we keep the soil in the field, the phosphorus is going to stay put. And that's why, when you look at the blooms that they used to have in the lake, and we fixed that problem by shifting a lot of acres to no-till and doing more conservation tillage, and there's hardly anyone moldboard plows anymore. That kept the soil in the field, and that reduced the particulate phosphorus, so phosphorus attached to the soil. That kept that from getting into the lake. The phosphorus we're dealing with now is dissolved reactive phosphorus. So that's the phosphorus from the time that granule of MAP that you go out and spread, from the time that dissolves in rainwater until it gets into the soil and has enough time in the soil to bind to the soil particles. That's that window of opportunity for that phosphorus to leave the field, either in surface runoff or through the drain tile. And so that's what we're trying to protect, is that window of opportunity. And so if we can reduce the amount that we have to spread, reduce the acres we have to spread it on, reduce the rate that we apply when we're out applying and only put what we need where we need it, then look at how much we can minimize that window of opportunity, that dissolved reactive phosphorus to leave the field. So yeah, to your point, there hasn't, nothing that I'm aware of has been done about how to stabilize that, but phosphorus is for the most part fairly stable. It's just that short time it takes is what we've got to protect. And that's why you look at the difference in blooms because of rainfall. Rainfall is what will move that dissolved phosphorus away and prevents it from binding with the soil. And that's why we see big blooms when we have a lot of rain and small blooms when we don't.
There's a little work in the manure space on spinning down that manure and getting phosphorus cakes basically out of that. They are developing new polymers to hold on to that phosphorus so that it's slow release when that is applied. A lot of that technology to spin it down and get rid of the water so you can spread it on the field. It's got very little phosphorus on it. But if you can't get that down to, I think it's like less than a penny a gallon, then it ain't worth your time. And so that's the issue, is finding out the cost-effective way to spin it down. But there is some polymer work, some of it's coming out of Bowling Green State University to slow release the phosphorus that we harvested out.
To Chris's point on that, at the Statler Farm this year, this summer, we're working with Teresa Dirksen from Mercer County that is going to be doing a demo of that manure separation technology to fine-tune the polymer so that we are under a penny a gallon. And then on the back side of that, we're looking at some technologies with a large company in the state that wants to take that dry material and turn it into a compost, into a value-added product. So you'll be left with a revenue stream if you can't spread that manure on your particular field.
One more thing. These are creative opportunities we have too. Because if you look, most farmers will say that if I have to haul that manure more than 10 miles, I'm losing money in the field. But But then most of these technologies, it's economy of scale. So if you don't have enough material, you can't get that price per gallon to where you need it to be. So then we need to start thinking cooperatively, like, here's where the processing facility is, and let's put it in a place where the shipping to that processing facility to eliminate the value, the economy of scales. And then, you know, these are the kind of things that we have to talk about, is cooperatively handling these and do it. There's opportunity for, which I love, is to solve a problem but also make a market out of this. That is a great win-win situation. Sorry, I have a problem. That's my wife.
So before she gives us the hook, I just want to put one more plug in for the types of audiences that we bring in, to her point of making sure that we're more effectively sharing our message. We talk to farm groups. We have a FFA Career Day coming up where we're talking to kids. A couple weeks ago, we had a vegan professor from Ohio Northern that was putting information in the newspaper about what he's teaching students. So on the small scale, we had him out. He came and he went in the hog barn and asked a lot of good questions and came out of there. He probably didn't go buy a pork chop after that, but he at least, you could wrap your head around what is going on in his mind of, he asked us, why would you want to farm 100 acres of corn? Like, he was just baffled by that. So we're making impacts there, but also to hammer home telling your story. We had the mayor of Toledo out, the prior mayor, and she came out with her staff. We showed her the hog farm, showed her the edge of field stuff. We showed her the soil sampling stuff that we do, variable rate. And when they left, they asked them what was most interesting to you? What did you learn today? And they said, we had no idea that agriculture was so sophisticated. And this is the mayor of Toledo and their PR people that are pushing information out about how bad agriculture is. And they had no idea what we take for granted on just basic soil sampling, VRT, everything else. So if you think you're telling your story, we're still not doing it effectively enough. So.
And so I want to leave you with, before we close, one thing you can do on your farm. It may be minor, it may be waiting a day to spread fertilizer. Something you can all do to change this story. And number 2, tell your story. Just like he said, the people in Toledo, it's easy to say, that bunch of farmers doesn't know what they're doing, okay? It's harder if you see a grandpa with grandkids, if you see a mom. Be a person. When you tell your story, you have emotion and you become someone that's important instead of just a dumb farmer that doesn't know what they're doing. When that happens, then people can understand where we're coming from, that this is our livelihood. This is how we make our money. This is how we raise our children. So it's important for them to understand that, exactly what Aaron was saying. And finally, if you have a question about your field, your soil test, anything, Eric is here, Rick is here, I'm here. These guys are available. Reach out to your extension office, your seed agronomist. All these people can help you out if you need help. So don't be afraid to find someone and say, hey, can you help me understand how to apply this fertilizer or how to do things differently? We're all more than happy to help you out. With that being said, if you have any more questions, these guys will stick around for a little bit. Otherwise, thank you for coming. Please be careful going home and have a great night.